Ibn al-Haytham, the forgotten father of modern optics. Before Newton explained light, before Galileo changed how we see the universe, one man had already solved the mystery of vision itself. 1,000 years ago, Ibn al-Haytham proved that the eyes do not send out rays, light enters them. He tested ideas with experiments, not authority. He used dark rooms, lenses, and observation to uncover how sight really works. His methods shaped modern optics, influenced the scientific method, and helped ignite the Renaissance. Yet today, his name is almost unknown. This is the story of the scientist who brought light into focus and was nearly written out of history. Imagine trying to understand the world without testing your ideas. No experiments, no measurements, just inherited beliefs passed down for centuries, accepted because respected authorities once said they were true. For most of human history, this was how knowledge worked. Light, vision, and the nature of sight were not studied through observation, but through philosophy and assumption. People believed that the eyes sent out invisible rays that touched objects, allowing us to see. This idea went unchallenged for hundreds of years. Then, in the 10th century, one man questioned everything. Long before Newton studied light, long before Galileo turned telescopes to the sky, a scholar named Ibn al-Haytham changed how humanity understands vision, optics, and science itself. Yet today, his name is rarely mentioned outside specialist circles. This is the story of Ibn al-Haytham, the forgotten father of modern optics. Ibn al-Haytham was born around the year 965 in the city of Basra, in what is now Iraq. He lived during a period historians now call the Islamic Golden Age, a time when science, medicine, mathematics, and philosophy flourished across the Middle East, North Africa, and parts of Europe. He was a polymath, a mathematician, astronomer, physicist, and philosopher. But unlike many thinkers before him, Ibn al-Haytham did not believe that reasoning alone was enough to explain nature. He believed that truth must be tested. Later in life, he moved to Cairo, then one of the world's greatest centers of learning. There, he was invited to solve a massive engineering challenge, controlling the flooding of the Nile River. After careful study, Ibn al-Haytham realized something dangerous. The project was impossible with the technology of the time. Legend says he feared punishment for failing such an ambitious task and pretended to be mentally unstable. Whether fully true or partly exaggerated, what followed is remarkable. During years of isolation, he wrote some of the most influential scientific works in human history. Among those works was a book that would quietly transform science, the Book of Optics. Before Ibn al-Haytham, most scholars believed vision worked because the eyes emitted rays outward. He rejected this idea completely. Instead, he proposed something radical. Light travels from objects to the eye, not the other way around. Light moves in straight lines. Vision happens when reflected light enters the eye. To prove this, he didn't rely on philosophy. He relied on experiments. He studied shadows, mirrors, lenses, and refraction. He carefully observed how light behaved under different conditions, and most importantly, he repeated his experiments to confirm his results. This approach, observe, hypothesize, test, and verify, would later become the foundation of the scientific method. Centuries later, this method would be credited to European scientists, but Ibn al-Haytham was already practicing it nearly 500 years earlier. One of his most famous experiments involved a darkened room with a small hole in one wall. Light from outside passed through the opening and projected an inverted image on the opposite wall. This simple setup, what we now call a camera obscura, demonstrated that light travels in straight lines and can form images. It was an early ancestor of the modern camera and a powerful piece of experimental evidence. At a time when science was still intertwined with philosophy and tradition, Ibn al-Haytham insisted that nature must be questioned directly. If an idea contradicted observation, the idea was wrong. no matter who originally proposed it. That belief alone changed the course of science. Ibn al-Haytham also made major contributions to our understanding of the human eye. He described the structure of the eye in detail, identifying components like the cornea, lens, and retina. He explained how light is focused and how images are processed, connecting physical optics with human perception. This was revolutionary. For the first time, vision was understood not as a mystical process, but a physical and biological one. His work laid early foundations not only for optics, but also for neuroscience and psychology, fields that would not fully develop until centuries later. What makes Ibn al-Haytham especially remarkable is his attitude toward knowledge. He wrote that a true seeker of truth must make himself an enemy of everything he reads, examining it from all sides. He warned against blind trust in authority and emphasized intellectual humility. In other words, he believed that science advances when we are willing to be wrong. This mindset, questioning assumptions, testing ideas, accepting uncertainty, is at the heart of modern science today. Over time, Ibn al-Haytham's work traveled far beyond the Islamic world. His writings were translated into Latin during the Middle Ages and studied by European scholars. His ideas influenced figures like Roger Bacon and Johannes Kepler, helping shape the scientific revolution that followed. Yet, as history was written and rewritten, his name slowly faded from popular memory. Science textbooks often present the story of modern science as a purely European achievement. The contributions of earlier scholars from other civilizations are mentioned briefly or not at all. This incomplete story does not diminish Newton or Galileo, but it does overlook the deeper global roots of scientific progress. Remembering Ibn al-Haytham matters, not because history needs correction for its own sake, but because understanding how knowledge truly develops makes science more human, more honest, and more inclusive. Science is not born in isolation. It grows across cultures, languages, and centuries. It advances when ideas are shared, challenged, and refined. Ibn al-Haytham embodied this spirit long before the modern age. Today, whenever light is studied, whenever a camera captures an image, whenever experiments are designed to test reality rather than tradition, the influence of Ibn al-Haytham is still there, quiet, foundational, and enduring. He may be forgotten by many, but his legacy continues to illuminate the world.